Hello students, good evening and very warm welcome to this electrostatics session. And guys, you are on JEE English, and let's do a thing today. Today we are going to get started with a very interesting topic around electrostatics, and you may want to stay tuned throughout the session. Do not forget to share the video. Hello, do not students, good evening and very warm welcome. Oh, guys. So yeah, you may want to share this video, and do not forget to like the video and click on that little subscribe button and bell notifications. And that being said, students, I am Murlidharan Gopalakrishnan. I completed my MS in electrical from CU Boulder, and I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And I filed 25 patent applications in India and abroad, and I have a track record of winning several national level science and tech competitions. And guys, the most competitive gamified IIT JEE battle ever is on. Yes, it's already on, and the second one is going to happen on 22nd of November. The first one has already happened on 8th of November. You can enroll today by using Murli Live code. This is not a paid event. You just need to make use of this code, and yeah, that's all you need to do. And guys, yes, it's going to be the most competitive gamified IIT JEE battle ever. Compete today and compete on the coming session and win some amazing rewards and prizes. These include Apple products, MacBook Air, like MacBook Air, and iPhone, and Amazon vouchers, etc. So make sure you are enrolling, and this is not just like a gamified experience. Of course, it's going to be super gamified, but it's also an academic experience. So this is a lot important for students who are going to appear for JEE and who are keen about the preparation, etc. And definitely, guys, prizes are there, and trust me, it's going to be super interesting for you. It's going to be of course a competitive one, but also a gamified one. So make sure you attend it, you compete, and win lots of rewards and prizes in that event. And yeah, of course, hundreds of Amazon vouchers are there as well. And that being said, students, if you don't have a Telegram app yet, just do download it from your Google Play Store and App Store. That's all you need to do. And why do you need to do that? Because you want to get onto JEE English Telegram channel. And what do you get by getting onto the JEE English Telegram channel? Before time updates on every class happening on JEE English. So we keep posting all the updates on this Telegram channel every day and before time. So that's the beauty of this Telegram channel. So you may want to get on to this and start getting this notifications, live notifications, before time notifications every day. And yes, you need to first of all download the Telegram app. You cannot just click onto this link. This link is available in the description box below. If you're noticing that all that with those words and etc., you can find it over there. And you need to download this from either App Store or Play Store, guys. So make sure you download it first. It's available on both, and more importantly, you get onto this Telegram channel, and you just type in under JEE_English to find us as well. And that being said, students, if you haven't covered units, dimensions, and measurements yet, and if you're a 2021 aspirant, guys, you're making a mistake. The reason is, it's the easiest topic that you can do for your JEE Mains and JEE Advanced preparation, and it's a definitely asked topic. Yeah, if you're a 2021 aspirant dropper, you are supposed to complete these 5 lectures. These 5 lectures are full-fledged lectures on like units, dimensions, and measurements. And guys, they just happened recently. You can check them out, and there is another one extra session that will be the 5th session. These 4 back-to-back session plus a 5th session on lots and lots of model problems. And all you need to do is get your pen and paper, attend the session. I mean, even it's a recorded session now, you can attend it and complete everything. And if you solve all the problems in the 5 sessions, and maybe you pick up also a book, I recommend you pick up a book, not just be dependent upon the lectures, because that habit will be carried throughout, and that's not a good habit, guys. And probably for units, dimensions, and measurements, but you of course, if you attend these 5 lectures, your preparation will be complete. Typically 2 to 3 model problems are asked in JEE Mains and JEE Advanced. You can notice this pattern. If you pick up your previous year papers, you wouldn't see a single paper without units, dimensions and measurements problem. And what all have we covered in these 5 sessions? Actually 4 theory plus problem mixed session, and 5th completely a problem oriented session. What have we done in this? We have covered units, dimensions and dimension analysis, units, equivalent kind of concepts, and vernier calipers, screw gauge, error analysis, least count. So possibly everything that you need for your JEE Mains and JEE Advanced preparation. And not only that, guys, there would be like an easy question. For an example, there was a question in JEE Advanced where it was based on least count. Okay, meter bridge, least count based concept, but you should have first attended units, dimensions and measurement, and that was a cakewalk. That was a cakewalk. The reason I'm saying is it's not just less time consuming during your preparation, and also it's not going to consume much time during your problem solving in JEE Mains, or when you're trying to solve a problem in your JEE Mains. You save a time. Easy, frequently asked and less time consuming topic. This is the kind of thing that you want to do, and mixed concepts in JEE Advanced. So try to cover this. It's going to be very easy. I typically recommend this, and it's all available for free of cost on Unacademy learning app. So make sure you attend it, guys. And that being said, students, if you haven't downloaded Unacademy learning app yet, download it from your Google Play Store and App Store. All you need to do is type in Unacademy, and the first search result is going to be Unacademy learning app, and then click on this install button. Once you do this, what do you get? You get before time updates on every class, and also live notifications on every class that is conducted by me and other educators that you would follow. So yeah, make sure you're following me. And not only that, you can give free of cost quizzes. Free of cost national level quizzes happening every Tuesday and Friday, and Tuesday and Thursday. And not only that, you can also attend Unacademy Combat. And guys, it's a convenient education app where you can attend classes from anywhere. So make sure you install it. Even if you're attending classes from web-based version, still notification is the thing that you want to get on time. And that being said, students, if you are looking for a champions tool, the best in class platform for your JEE preparation with the best educators across the nation, it's going to be Unacademy subscription. So all you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and click on this get subscription button. And once you click on to this get subscription button, it's going to be one subscription, unlimited access, and that too with the best educators across the nation in a structured program where you will move systematically throughout your JEE preparation. It's meant for you to become a champion in your JEE Mains and JEE Advanced preparation. Hi Kushi, hi, good evening guys, good evening. And yes, so yes, not only that, right now there are classes being hosted by me on optics, and there are classes that are being hosted by our team, our JEE English team, and that too in English on Unacademy subscription. And we also have the best educators across the nation and legends like DC Pandey sir on this one platform, guys. And yes, you will get access to leaderboards, dashboards, and again a competitive environment with a kind of environment where students come up with different approaches, and you can ask me doubts as if you are present in the class. So it's kind of the virtual classes, but with all the kind of daily interactive things that we do. You are not missing out on any part in your offline classes. And even if you're planning to use it as an auxiliary tool for your JEE preparation, this could be the one for you, because we have dedicated extensive programs where you not only undergo daily interactive sessions, but every fourth session is going to be a doubt clearing session with quizzes and mega quizzes. So make sure you're clicking on this get subscription button and taking advantage of this unlimited access, guys. And it all comes at the cost of less than 2,100 per month, less than 70 rupees a day. Absolutely. Yeah, it's going to be a very useful platform for your JEE preparation. Of course, you get all the free of cost lectures on JEE English, free of cost quality lectures on JEE English. But Unacademy subscription is altogether a preparation oriented thing. So if you're a hustler, if you're trying to learn about physics, you can of course come to my classes. You can attend my team's classes. We have like awesome team on board, like IITians, NITians, head of coaching institutes. So this is the kind of team that we have on JEE English. And guys, typically my classes happen at 7:30 p.m. from Tuesday to Friday. Yes, this is my timing, and here on JEE English as well you get quality lectures for free of course, but there is a difference between Unacademy subscription because it's about test preparation where you're getting access to national level test series, timing, and the daily interactiveness that you get there is like nowhere else. And this all comes at a price of less than 70 rupees a day with the kind of things that you want with the best educator across the nation, only at the cost of 70 rupees a day. And guys, do not forget to apply Murli live coupon to avail the best discount. The best discount is something, if you want to get it, apply Murli live coupon, don't miss it out. And yes, this is going to be the thing that you want to do to get to this price point as well. And typically this is a 24-month program meant for 9th class, 10th class, or even 8th class students and 11th class students. So if you are in 8th, 9th and 10th, or if you're beginning in 8th, 9th, 10th and 11th, this is going to be the program for you. It's a 2-year long journey, and you would typically see even the programs are structured that way. And we also have convenient payment options for you where you can split your payments into multiple parts and you don't have to go through the burden of paying all the fee at once. And this is our paying parts in-house option. We also have access to no cost EMI where you can split your payments into multiple parts and you don't have to bear any interest on your easy monthly installments. 2 interesting payment options which you want to check out before purchasing your Unacademy subscription, or if you're planning to purchase an Unacademy subscription. And through this you don't have to go through the burden of paying all the fee at once, and you will be able to choose the right kind of program, either a 12-month or a 24-month program depending upon your aspiration. Of course, you're going to make make your decision depending upon what kind of program you want, but I recommend if you are a 2022 or 2023 aspirant, you go for a 24-month program, and if you're a 2021 or a 2022 aspirant, 2021 aspirant is what 12-month program is generally meant for. At least you can take 8 to 12 months, and you can use debit card, credit card and UPI as well on our platform. Alright guys, and if you're a dropper and long term, a 12-month program is for you. And what do you get on this 12-month program? Droppers batch, and the classes that are oriented towards 12th class and droppers batch. We have 6,000 plus recorded materials, 1,000 plus live programs going on, all at a cost of less than 2,900 per month. And do not forget to apply Murli live coupon on your subscription purchase, any of your subscription purchase, to avail the best discount. So make sure you're choosing the right kind of program and you're not hesitating to give the test series, and stay dedicated. Be it on Unacademy subscription or JEE English, if you're just a hustler and if you're planning not to afford one, or if you're thinking not to buy an Unacademy subscription, still if you're on JEE English, stay regular. If you're on Unacademy subscription, guys, that means you're sincere. But at the moment, just because you bought it, it does not mean you're going to become a champion. You need to stay sincere. And that being said, Optics Basics to Advanced courses live on Unacademy subscription. If you're already on Plus, enroll soon. If not, if you're planning to purchase Unacademy subscription, enroll guys, because this is going to be a comprehensive, full-fledged coursework on optics. So this is going to be a comprehensive, full-fledged coursework on optics, which will take you from the basics and you will move until advanced without any hassle. You don't have to have any prerequisites. And guys, it has just been launched. We'll be covering anywhere around 65 plus sessions with 100 plus concepts, 300 plus model problems. Guys, this is the kind of thing that we are able to do on an Academy subscription platform. And of course, many of you do understand the kind of platform that you get over there, etc. So the kind of educators, the kind of environment, it's like a whiteboard lecture. So there are a lot of differences between JEE English, but JEE English you get quality lectures for free, of course, that too completely and exclusively in English. So do not forget to share this video and like this video. And yes, if you're on optics, do enroll today, and it has just been launched, guys. If you're already on Plus and if you're missing out this course, this is something that you don't want to do, especially if you're preparing for optics or if you're planning for a career in optics as well. Of course, it is going to be JEE oriented, and of course, I bring up all the concepts from my learning. I have my degree as well in optics, where I've taken one of my concentration to be in optics. So you will get to know about a lot of different kind of information around optics while attending this coursework. It's not going to be just a regular coursework, and of course, the focus is going to be JEE Mains and JEE Advanced. That is the key motto that you're over here. You can do your learning as well later on, but yes, make sure you're enrolling to this optics coursework, guys. And remember, practice, and practice only makes human perfect. And today you'll realize that it's only part of electrostatics, where you have to give a decent amount of practice. The concepts are easy, the problems are easy, but you need to understand the way to work around it. So let's get into the lecture. Let's not wait anymore. Do not forget to like this video. Do not forget to share this video. Do not forget to share this video on your social media, guys. Think about it, students who are seeking free of cost lecture, quality lectures. They would get access to this kind of video content. So make sure you are sharing this channel and liking this video, clicking on that subscribe button, because clicking on subscribe button is bell notification is for you, so that you can get on time updates on every class happening on JEE English. But sharing is for rest of your friends on social media, or rest of the students who are looking for English lectures for JEE preparation, and that too like quality lectures, etc., like in-depth quality lectures. So yes, let's move on to this topic, guys. But the thing is, this is electrostatics. So what you want to do is you want to get started. Okay, today we are going to deal with a very interesting part. Not just this, we have done concentric shells, but this is a different part of concentric shells, and try to maintain completeness. I know it's like a lengthy topic, 20 topics in 20 lectures, and you're thinking that what, the lecture is still on, whereas in the rest of the topics it were completed. But electrostatics is going to be lengthy, but it's easy, guys. Trust me, it's one of the easiest things. There are anywhere around around 10 kind of different concepts for your JEE this thing, like exams, like spanning from, we haven't started yet, with electric dipole, electrostatic potential energy. So these are all very different concepts, but if you maintain completeness in them, you can typically score in your JEE Mains. Especially in JEE Mains, it's very easy. JEE Advanced also is going to be easy, given that you cover a little bit part of mechanics as well. So okay, generally a combination of electrostatics and mechanics can be expected. In JEE Advanced, we'll do that during our PYQ session. We'll be soon having a PYQ session on electrostatics. But now get started on it and try to cover rest of the lectures. Do not waste your Diwali. 2021 aspirants, it's a sincere advice for you. Do not waste your Diwali. Of course, enjoy. Of course, have your sweets. And of course, a cracker is not a thing for many of you. And it's best, if you are spending your time fruitfully at the moment on maybe like JEE English or Unacademy subscription platform, and especially if you're on Plus, try to cover the optics course. And if you're planning to get started with electrostatics, do it. Only few lectures, and also don't miss out the quiz-based lectures where we have discussed concepts. And don't hesitate to attend the quizzes. They are just free of cost quizzes. You can attend them. All right, that being said, let's get started on this topic. Three metallic shells A, B and C of radii A, B and C have surface charge density sigma, minus sigma and sigma, minus sigma and sigma respectively. It is found that, so let's say we had a charge and I moved this charge Q0 from A to C. Okay, this is the initial position. Okay, this is the initial position, or Ri is better than Xi. If this is the initial position and you have moved to this final position. Alright, so this is the final position. Right, so this is our final and this is our initial. Now the thing is, you need to find out what would be this radius ratio or relationship between the radii of sphere A, B and C, such that no work has been done to move this charge from the surface of the shell A to the surface of the shell C. It's a mathematical problem, guys. Hi Akif, hi. Get started, guys. Get started. Try to solve it. It's going to involve a lot of math. So this should be like a small b. So make sure you correct this. But get started. Typically a JEE Advanced kind of problem you can expect in your JEE Advanced. Take your time, like I would say 2 minutes is what you should take. 2 minutes is what you should take when you're getting started with this problem. Is it a JEE Mains? No, I don't think so. In JEE Mains you'll have this. No, that's not true. It can be a JEE Mains problem. So get started on it. It's not just going to be a JEE Advanced level problem. It's going to be also JEE Mains problem. Typically you can't expect what is going to happen in electrostatics. So be as much prepared as possible. Hi Akif, hi Kushi, hi everyone. Very good. Amazing Kushi, really good, really good. What is the work done? Very good. Students who got the answer, very good, but good. Q naught, and this is the Q naught. Now the thing is, I moved it from year to year and I haven't done any work. How is that possible? So what is this being said? Work external is equal to 0 when I am moving the charge position, initial position, charge final position. Now the thing is, I've moved it from the initial position to the final position, and I've seen that no work has been done. So WQ naught, when I moved it from the shell A, you can exactly call it shell A. In this case, it's not even RA. You can write it down as just A to C. Okay, but let's keep it now for our understanding, to R to C. So what has been done in this case? So can we say something like these 2 points and this surface, let's call it a surface 3, this is a surface 2, this is surface 1. Can we say that potential at surface 1 is equal to potential at surface 3? That is when you don't do any work. That is when you don't do any work. You don't do any work to move from A to C. Simple. If you understood this, this is a cakewalk. And rest is a little bit of math, okay? From A to C. Easy. You can even write down the equation for work done. You can use a Q naught. But I think directly identifying this thing would be more simpler. Because what is your work done going to be? If I'm going to move from A to C, it's going to be delta V into Q naught. Okay, and this is going to be like V C, because that's the final position, minus VA into Q naught. Is that it? Maybe I'll just not return it in a different color, but let me just highlight it. Okay. Easy. Same thing. If delta VC is going to be 0, if this term is 0, that is when work external is also 0. Crash course, I would say it's not a full-fledged crash course, because in crash course you won't be covering every concept, and there is a difference between the kind of students that would be attending the crash course and a normal course. Crash course is meant for students who are already well equipped with the concepts, and all I have to do is say, okay, this is the situation, here you change this. We'll do a similar thing, but I believe we are now focused on understanding electrostatics. Even if it's not a crash course, guys, it is worth covering a few topics. One would be electrostatics, optics, current electricity. Of course, current electricity is the king. Current electricity and magnetism is the king. If you cover those both topics for your JEE Mains, you have covered like 5 questions. 5 questions is what you have bagged by covering just 2 topics. That would take, of course, 3 months, but that is a lot of weightage that you are getting for it. And optics, 2 questions. Electrostatics, it's little easier, less number of concepts, more practice. Current electricity is more number of concepts. and also a little bit of practice, but 3 questions is kind of the questions, is the kind of number of questions that you can expect in current and electricity. Okay. Alright, now let's move on then and get started with it. First of all, we need to calculate the potential at surface A. Potential at surface A, now I'm going to label everything as A, B and C. So to calculate potential at surface A, we need to find out few things. First one would be, what is the charge on surface A? What is the charge on surface A? It's going to be sigma, because charge density on this is sigma into 4 pi r, or a square. Very good. What about charge on the surface B? Surface B, it's going to be sigma minus sigma. Minus sigma, don't miss out the sign. Okay. 4 pi b square. And also one more topic would be nuclear, guys. Nuclear, I think semiconductor is also good if you can cover it. You will be able to bag some marks without putting in much efforts. And semiconductor, sometimes you can do it even in a few days. If there are like few choosy topics that you want to do, you can watch these strategy videos and get an understanding of how you need to move around it. So now this is the kind of charges that are present. We know this thing. Okay, this is a standard thing. We are going to just directly, if you are writing down, taking down notes, note it down, because we are not going to write this again. Okay, this is going to be the charge present on shell A. Charge density into the surface area. It's surface charge density, right? Minus sigma, because this time the surface charge density on shell B is minus sigma. So this is the charge present on A. Let's say now for now this is plus, it might be minus on B if it's plus, or if it's minus on A then it's going to be plus on B. So like, you understood that point, like how the charges should be distributed. Let me quickly correct this thing. If you have a perfect understanding of this, why this is happening, because it wouldn't have been true in a normal scenario. Why not? Because in a normal scenario, when we discuss the shell-based questions, you might have observed that, the innermost shell would have the max potential. But here things are changing a bit. Maybe it's a positive charge on shell A, on the surface of the shell A, and it's a negative charge on shell B. Okay, it's a negative charge on shell B. So this is, don't get confused during your exam where they give you cannot be determined. No, don't touch that, cannot be determined, when it's not like charges but unlike charges. Okay, somewhere unlike charges are present, or it's not connected, etc. Then in that case you move by concept. Rest is, as I told you, is math and electrostatics, a lot of arithmetic, not even sometimes a complex math. You need to do the arithmetic and concepts as well. Okay, some few part is like having a lots and lots of concepts. So this is the kind of thing that you want to expect during your JEE Mains and JEE Advanced. Okay, JEE Mains also this can be asked, because it can be a conceptual question. Can the surface potential of shell A and shell C be equal? Yes. In this case, it can be equal when you are given a negative charge distribution on one of them. Okay, try it out mathematically and you will get the answer. So what is the potential on surface A? Surface A, the potential is going to be surface potential of the A due to, okay, let me do the standard thing. So the thing is, what we used to do, we used to call each surfaces with some name. This would be surface 1, this would be surface 2, this would be surface 3. So 3 kind of potentials would appear. In this case, I'm going to call this as V dash S1, V dash S2 and V dash S3. Okay. So what is the potential due to the charge present on surface 1 is V dash S1. What is the potential on surface S1, or with the sphere with the shell with radius A, due to the the charge present on S2 is V dash S2, and V dash S3 is going to be due to the charge present on surface S3. What is the potential created? Okay, that is it. It's a pretty easy question if you have noticed it. It's going to be K into K into QA divided by A. Okay, first one is going to be just KQ by R, and that being written this way, it's going to be just KQA by R, and in this case R is A. The second one, V dash S2, what it is going to be? It's again KQB by B, isn't it? It's KQB by B. Basically, surface potential of B would be reflecting inside, because inside potential is going to be constant for shell B until it reaches shell A. Okay. Okay, for shell B, okay, this we are making use of superposition principle. So this would be like KQC by C, since it is inside shell C. Substitute the values, but if you have noticed the thing, what does QA correspond to? Some 4 pi A square, 4 pi B square. QB corresponds to 4 pi B square, and C corresponds to 4 pi C square. And one difference is there is some negative sigma over here. So we can say, we can take out 4 pi sigma as common. During this calculation, if we take out 4 pi sigma into K as common, what would we have? We would basically have A square by A minus of B square by B, because it's a negative surface charge density, or unlike surface, whatever you like to call it. Okay, C square by C. Calculate it. It's a pretty easy equation. You'll get something like A minus B plus. So potential at surface A is how much? From this we came to know about it, and it was supposed to be something like 4 pi K sigma. Let's put it out in the way we would like to learn, and it's going to be A gets cancelled out, B gets cancelled out, C gets cancelled out. You'll have something like A minus B plus of C. Simple, very simple it is. Alright, now we need to do the second thing. The second place where we need to calculate the potential is going to be the surface of C. Okay, let's name it as surface S1, S2 and S1. Okay, S3, S2 and S1 as usual. But now the thing is, what I'm going to say is little bit different thing. I need to calculate potential on surface C. Things will change, of course. If it doesn't change, like what is the use of radius being varying over that point? So if I'm going to say potential at surface C, we need to do a superposition of surface 1's charge. Surface 1's charge is influencing the potential on the surface 3. I'm going to call that as VS1 double dash. And due to surface 2, again there is going to be a potential on surface C. Surface C is what? This is the surface C, right? Alright, and there would be like the surface potential of C itself. I'm just going to call it as VS for 3 due to the charge present on the surface 3. It's a simple question. If you have noticed it, again what we need to do now, this time things will change a bit. KQ by A, no, it's going to be KQ by C. The next time, it's when you're going to write it for surface 2, it's going to be KQ by B, no, C. Again what? KQ by A, B or C, it's going to be KQ C by C. It's basically surface potential. Now what I'm going to do is, okay, let's write it down this time, because this would give us the best clarity. 4 pi A square into sigma was the charge present on surface 1. Okay, divided by the distance from its center, which is going to be C unless it is not inside the shell. Now the second one, it's going to be K into 4 pi A square or B square into sigma. Why minus? Because it's a negative surface charge density, divided by C. And the third one is going to be K into, okay, this is the charge present in C, it corresponds to B, and charge present inside B is going to be 4 pi sigma C square by C. Easy? So far everything has been so easy, and trust me, it's totally easy. Okay, math is the thing that you need to work around here. If you have noticed it carefully, it's kind of equating VC and VA. There you would observe something very interesting. Okay, we have 4 pi K sigma common out again, but this time we will have another c as common. C would be the common denominator. I would like to keep it just the way it is. It's going to be a square minus b square plus of c square. Now what you need to do, you need to equate VC and VA. Of course, work is not done. If you're moving that charge, even let's say it has been set from the center to the surface S3, if some work is not done, it's also true, right? Y divided by C. Suraj, I believe you missed some session. So you mean this C? Is this one clear, Suraj? Is this thing clear? Why A over here, is this clear? Yeah? Is this clear? Why KQ by A? Even if it was at center, it's going to be KQA by KQA by A, KQB by B, KQC by C. Here why C? Because we are calculating at the surface potential on surface S3 on this sky, on the outermost shell. So the charges should appear as if they are concentrated at the center. So a point charge, how you would be writing it? You would be writing it that way. Try to attend previous lectures. This would be clear. Okay. So it's basically why C, students? It's C because we are calculating at surface C, right? S3 on the surface S3 on the surface C. That is it. All right. I hope you believe. Not here. So this would be C, Suraj. Okay, this would be C. Because you would assume as if for shell A the charge is concentrated at center, or let's say for a hollow shell, how do you calculate a potential outside the surface? Inside the surface, it's going to be KQA by A. Anywhere inside, it's going to be KQA by A. Anywhere outside, it's going to be depending upon the distance from its center. So let's say you are calculating at point C from center, distance C from center. If you are going to calculate it from distance C from center, what is going to happen? Let's not call this C. Distance C from center, what is going to happen? In that case, it's going to be KQA, charge present on the shell A, divided by radius C. And radius not C but distance C. Okay, let me correct it. Distance C. Okay, distance from the center again for shell B, what it is? It's going to be C. Right, for shell B, it is going to be from the center is what you are going to be worried, right? You are not worried about let me do a thing. Let me give it a different color. For C, this is going to be for B. For a sphere B from the center, it's again distance C only. Okay. Oh no, VS3, I've just labeled it as VS3 because this is the potential kind of superposition that we are talking about. VS3, you are you must be attending every day's lecture. Guys, don't miss out in a single day lecture. So this is due to charge present on surface S1. This is due to charge present on surface S2. This is due to charge present on S3. This is basically due to charge QA. This is basically due to charge QB. This is basically due to charge QC. Similarly, over here we have given it, it's just a naming convention. We have given it a name like V-S1 because this is due to the charge present on sphere A. S2 because this is due to the charge present on surface B. This is due to the charge present on surface C. Suraj, I think the reason you are not getting is you have run behind the schedule. Okay. Don't create backlogs, try to cover it in this Diwali because Suraj, I've seen you before. This concept must be clear for you. Okay, let's move on and let's equate no work done means VC is equal to VA. Guys, consistency matters in terms of how you are going to prepare for your JEE Mains and JEE Advanced examination. Okay. Plus C square divided by C is equal to, I'm just writing down the same equation, 4 pi k into sigma A minus B plus of C. Okay. Now just focus on this now. For now, assume it because even in that case, even in the earlier case, we would not be reasoning it. We would be going by the postulate proposed by Coulomb, where he said that if there is a conductor And if you like a spherical conductor, and if you infuse some charge on its surface or even inside, it will still be on its surface. And in that case, all the charges would appear as if it's focused at the center. And it was also said that even for non-conducting, it is for spherical charge distribution, it is assumed as if the charge is placed at the center. Okay, all right. So cancel out 4 pi k sigma and a square minus b square plus c square. C on that side, what it is going to be? AC minus BC plus of c square. Really good, Kushi. I know this was very fast. It could have been very fast, of course. So take out c as common. You will get a minus b on this side. This is basically a square minus b square. A minus b into a plus b. Cancel out a minus b. A minus b. What you would be getting? C is equal to a plus of b. That math, just math, right? All right. Yeah, equate it. Eventually, you'll come to a solution. Don't get into sort of an anxiety during your exam. Quite simple. Of course, the options will be given as if to confuse you. Work around it. All right, let's move on to the next question then. I think this was an interesting question, but even more interesting is what we have now. So when isolated the spherical shell A as potential V, when connected with an uncharged spherical shell B, the common potential becomes 2 by 3V. If radius of sphere B is 4 centimeters, then what is the radius of sphere A? Get started on it. Guys, watching live, watching recorded, get started on it. Don't miss out even, the calculation part of it. Calculation is also part of your JEE Mains and JEE. So first of all, I would typically recommend during your practice session, if it was not exam, you will be moving as quickly as possible. But during your practice session, let me ask you a question, that if the potential is becoming 2V by 3, it's 2 by 3V, that's same as 2V by 3, which is greater than V by 2. Then in this case, so 3 conditions would arise. Of course, one condition is not true. Should RA be greater than RB, RB be greater than RA, or RA being lesser than RB, or RA equal to RB? Think about it carefully and move. Of course, I've given you options in all the ways possible. But if you understood this, you can probably eliminate at least 2 to 3 options. We eliminated 3 options. Bravo! There you go. You got the answer even without putting in the effort. Okay. Let's say if this was the condition, right? Like RA is greater than RB, then A is the answer. But probably you want to check it out. It's kind of a practice problem, so try it out and take a moment and think about it. What should be true? So these are some ways of thinking about it. What has happened to potential as reduced by 1/3? Right, potential as reduced by 1/3. If it is a smaller sphere, do I have to give more charge or less charge? So whenever you are trying to move your thinking in that direction, what you need to do is, first of all, during a practice session, this is something that you can do. Take a radius for A. Okay. Typically, 2 things can happen. Your assumption is wrong, then the reverse of the assumption is true. Your assumption is correct, so what you assumed is correct. Okay. Let's say A is equal to B. This is the easiest case, and potential V is present on A. Okay. You will come to know about it. Like what would be the charge? It's going to be KQ by A. Hence, you can say the charge is going to be K into A divided by. So RA. Okay. In this case, let's keep it as RA divided by. Just a moment. KQ by A. So the charge would be VA divided by K. Okay. So VA, potential on this is VA. Okay, let me get this quickly. So the charge would be QA would be, just a different way of thinking about the problem while you are getting started with this kind of concept. QA is going to be what? like just writing down from the equation initial charges. Of course, you have to conserve charges. There are a lot of process involved in this problem, but just sometimes this can work. VA into RA divided by K, which is a constant, basically proportional to both potential and rate. So finally, let's say two spheres are connected. In that case, charge will not be equated, potential will become equal. So let's say A and B are connected and both are of the same radius. Both are of the same radius. So A and B are like two shells and they are just connected, or like two spheres, they are just connected. They should be of the same radius. In this case, what do you know? You know something like VA should be equal to VB, that is V dash A is equal to V dash B, which also tells you from this expression it's proportional to radii. Okay, the distribution would be happening according to the radii. So you will get some kind of like using this and charge, you'll be getting a relation like this can be called as QA. Now let's call this as QA dash. QA dash, just showing you a shortcut, QA dash plus QB dash from conservation of charges should be equal to QA. Okay, just building that kind of thinking at the beginning itself if you're noticing the question for the first time. The shells are kept far away, but it can be far away, it can be concentric. Okay, the shells are just connected. Okay, what is told to you, the shells are just connected. Maybe they're just kept far away, but they're connected. Then with the metallic wire, that has to also be that should have also been told. Then the potentials would be equal. Okay, Aaron, there is no other concept other than the potentials would be equal. That's it. Potentials would be equal. That is all you have to think about. Okay, so in this case, you can, if VA is equal to B, both should have same charge on them, right? That is when they will have same potential. Hence, 4 is not done. Okay, let's change our assumption now. Let's change our assumption saying that, I think maybe, it's just an assumption, right? I think maybe, A is greater, okay, B is greater than B. Or A is greater than B. Okay, for now let's take A is greater than B. If A is greater than B, the expression would look very similar. Okay, the expression would look very similar. From that thing, just try to calculate it. Take this to be like V. Okay, common potential V, in this case it's 2V by 3. And write down the equation. You'll see something like RA plus RB is equal to some VA divided by V into RA. You need to think about the quantity VA by V. Okay, you need to think about the quantity VA by V. So if VA by V is equal to the charge, if V and VB, VA is equal to if VA is equal to V is equal to VA by 2, then in that case it's going to be 2 on the numerator, then the charges has been 2 on the denominator. So just a moment, so V would be carried down, KK would get cancelled. It's going to be VA divided by V, final charge has to be conserved, and of course potential would decrease in any of the cases. And if it's VA by 2, it's going to be 2Q. Okay. My bad. Okay. So if it's V by 2, just a moment, guys. VA divided by VB, and you have some QA. Okay. If okay. It's going to be like what? It's going to be in the ratio of RA. So you'll be getting some expressions around RA, where it would be like VA by V into RA minus of RA. So we can take this to be like it's just a shortcut, guys. It's not mandatory that you understand this part. Even if you do the normal technique, you will get it. This is what the expression that you would get is equal to RB. So now think about it. If V is VA by 2, then both are equal, RA is equal to RB. So let's say now A is greater than B. Okay, if A is greater than B, on the other side, what would you get? Just manipulating this equation a little bit, you'll get something like VA minus V by V is equal to, I'll go to the usual method, RB by RA. If VA is greater than V, in this case like just 2 by 3, your RB should be greater than or less than, should be greater than RA. Okay, should be greater than RA. So that means this is also not correct. Okay, or else you can keep RB to be greater than RA or A to be greater than B, that kind of thing. Then A is greater than B, then what should happen if you calculate the potential? So this would be like a fraction, this would be a fraction less than 1. So think about it. Now let's say RA is greater than RB, like 1 by 2, take it to be 1 by 2. So you would get like 3 by 2 V is equal to VA. That means VA is 2V by 3. Okay. Alright, that was just a solution. But now take, okay, we'll work around it. So RB divided by RA, take it to be some other quantity, not 2, maybe like 3, and try to understand around it. Or if you take RB to be greater than RA, then in that case it's going to be VA is equal to 3V is equal to plus V is equal to VA by 4. That means VA should be lesser. What's your question? Gx tan theta is equal to Gx square divided by, I'll come to your question. Which formula is this? I'll come to your question. Let's get started on this problem. So this is the way of intuiting it, but typically if you want to understand the concept, if you want to move by concept, it's a very simple concept. It's not but sometimes that can be easier, once you're arriving to a solution. So let's say there are two spheres. So one sphere is A and one sphere is B. This guy is uncharged. This B is uncharged. Okay, this is charged. Okay, now what you have done is initially this had a potential of V. We understood it would have some charge Q initial on it. Let's keep it to be Q initial for it. So Q, okay, forget the earlier method. If you understood it, well and good. If you didn't understand it, focus on this. So Qi is equal to, from KQ by V is equal to KQ by KQ by R. This, let's call the radius to be like A, okay, and for this to be something like B, okay. So this should be like QA is going to be VA divided by K. Now what is happening is, this is initial. Now what is happening is, you have connected both of them. Then thing changed a bit. Instead of V, they acquired some common potential. They would acquire some common potential, right? They would acquire some common potential. What would be that common potential be? Of course. I will have a look at your query. Okay, we are dealing with electrostatics. I'll have a look at your query at the end. Okay, don't worry about it for education. Okay. If you haven't understood the earlier method, now as we do the math, you'll understand it. So don't worry about it. That is somehow, I substituted the value such that I got the answer. But now because I know it was 2V by 3, right? So that was the reason I got the answer. Okay. So now, but let's say 2V by 3 is not given to you, V is greater than V dash is given to you. In that case, you may want to apply that. Okay, so in this case, it's going to be 2V by 3 is this new V dash, and this guy would also acquire 2V by 3. Right? They're connected, right? Now they are connected. Once they're connected, both would acquire same kind of potential, but charges would flow from whom? From the charged sphere to uncharged sphere. This is also one of the kind of questions. I didn't bring it up maybe during your JEE Advanced practice. DPP we'll not do DPPs. We have already done a lot of questions. But what we will do is we will bring up questions around JEE Advanced, PYQs, etc. like a short way of dealing with PYQs. During that time, you will notice, you know what, this is one of the kind of questions that is being asked. Where does the charge flow from QA to QB in this case? Because it's simply uncharged. They have to equal potential, have equal potential. Trying to understand this radii relation is a very interesting thing to do. So now finally when connected, potential will be equal. Okay. So don't get confused around that thing. If you didn't understand it, you'll eventually understand it after this derivation. So stay patient, guys. So I'm going to directly write down QA dash. Okay, and what is Q final is equal to Q initial. Okay, so we don't have to think about it. What is Q final? They would have a Q final which is going to be equal to QA dash plus QB dash. And we know this is going to be not V, but this time 2V by 3. How am I writing this, guys? You know it, I guess. If not, I will shortly explain you. I'll come to your question for education at the end of this lecture. I think I've seen your question, but can you post out a detailed question? And guys, you can comment and post out, you know, detailed question like how Suraj does, so that I get an understanding. So this comes from, you know, V generally potential is equal to KQ by R. In that case, I can write it down as you know, Q is equal to V into R by. Okay, really that simple. So now we know one thing from conservation of charges, QA dash plus QB dash should be equal. Okay, from conservation of charges, we know Q initial is equal to Q final. So did I say QA is equal to QB? That is not correct, but QA dash is equal to QB dash. Q initial is equal to Q final. Charges does not disappear anywhere. There is no ground in this case. Charges would not disappear. Alright, now add QA dash plus QB dash. B have an equation something like this in this case. B into A divided by K is equal to, for now let me do a thing. Let me just keep it as V dash, so that we understand the thing that we discussed in the beginning the best. Okay, for now let's keep it as V dash. This is going to be what? V dash should be common, right? Both would have same potential. Just put it out as common. Of course, there would be K in both. There would be A with one, B with another. A and B are radii, right? RA is A, RB is B. So just writing it out. There we discussed it as RA and RB. Okay, let me quickly erase this point because I believe you understood it. Later on, it will be useful for us to write it over there. Okay, so now V is initial potential, and you know, this is like the final potential. Now let's do a thing. KK, you know, would get cancelled out. You would have an expression something like this. B divided by V dash or V initial. Okay, this is just for understanding. You can write it down if you want. 1 plus B by A. You can keep this expression handy if you want. Okay. B final minus 1 is equal to B by A. Now, the question is whether A is greater than B or B is greater than A from this. That's where, you know, we landed up over there. Yeah, you simply substitute it, you will get the answer. Okay. Here it will be like 2V by 3. You will take it on the other side, you will get all the answers very simply. We get A to be 2B, right? That's a different thing. Okay. Now think about it. Now let's do a thing. Do this exercise. This could be a useful exercise. So V initial by V final minus 1 is the ratio of B's to A. B by A, okay, B is greater than A, you are going to get something plus 1. from this expression, now think carefully. If A is greater than B, then that expression, this expression is what I'm talking about, ratio of potentials. To think about where the charge would flow from where. If it had, like, both of them had some potential, then that is how you should work. If A is greater than B, your expression is going to be less than 1. We'll call this expression as E just for now. And the other scenario is where B is greater than A. Then your expression is greater than 1. If your expression is greater than 1, Vi by Vf is greater than 2. Can we say that? Vi by Vf is greater than 2. If B is greater than A, Vi by Vf should be greater than 2. Isn't it? So if Vi by Vf is greater than 2, what is going to be the relation between V initial and V final by 2 in this case? This is where we are keen about, right? Then your V final would always be lesser than V initial by 2. Alright, your V final would always be less than V initial by 2. The other situation would say that if you calculate for the other situation where less than 1, take the one on the other side, the other situation would say that V final should be greater than Vi by 2. So if at all your potential has become greater than 2 or remains greater than 2, that means A is greater than B. If A is greater than B in this case, which is that answer where A is greater than B. So these two are the answers. Both are not valid. Okay, because this is where A is greater than B, since B final, I think this was a better way of understanding rather than just trying to understand it in terms of fraction. So let's do it that way. So since V final is greater than B initial by 2, it's 2V by 3. Of course, if it was less than 2, that would have been easy. You could have directly marked this answer, but that is for you if in exam you get it less than 2. Alright, now from this we can calculate it. Don't worry about rest of the things. Just substitute in this equation. V by A is equal to V initial of V final. V initial by V final divided by V initial minus V final. V initial divided by V final minus 1. So V initial was V, V final was 2E by 3, and VV gets cancelled. Here there you would have minus 1. It's a simple math. Now there's it's basically 3 by 2 minus 1, so you'll get it to be like 0.5. 0.5 B by A is equal to 0.5. V by A is equal to 0.5. So 3 by 2. So B should be 0.5 times A. That means A should be 2B. I'm really sorry, writing it down as. So A should be, A is what we are supposed to find out, right? A should be 2 times B. We are given the value of B as 4 centimeters. I think it's a little bit, it has been a little bit complicated than what it is, but I'll explain you why I did it. Like, let's say you are not given 2V by 3. So in this case, you have got the answer, it's 8. So don't worry about it. It should have been a multiple of 3. Sorry, 2. I'm really sorry again. It should have been a multiple of 2. Okay. Anyway. Now what I'm stating is, like, let's say instead of 2V by 3, something like V dash is given to you, then how would you work around this problem is the question. So instead of 2V by 3, some V dash has been given to you, and they would typically say that V dash by 2 or V dash is greater than V initial by 2, something like that. Then in that case, try to quickly understand, okay, this has been an uncharged sphere, okay, Obviously they would be equating potential. If one was at a higher potential and one was at a lower potential, charges would flow from lower potential higher potential to lower potential, so that the potential can be equated. Okay, so what I'm stating is there are two spheres. Okay, one sphere at a higher potential, this is a case where one is like a 0. Okay, another kind of questions you get is how does the charge flow? Carefully try to understand this point. There are two spheres, A and B. Okay, A is at a higher potential, B is at a lower potential. Your charges will flow from higher potential to lower potential, just like how your water flows from higher potential to lower potential. How you if you throw a ball, if you keep a ball from the top and it will come down as it comes down from a higher potential to lower potential. Similarly, the charges will also flow from higher potential to lower potential. Now the thing is, one of this shell is okay. So in that case, it was quite easy to flow from. Let me write it down for you. Write it down, guys. This is an important thing for your preparation and as well as understanding. Charges. Which kind of charges? Positive charges will flow from higher potential to lower potential. Typically one of the asked questions. Right? Think about it. Potential has to be equalized. Then charges move from higher potential to lower potential. But which kind of charges it would be? Would it be negative charges or positive charges? Positive charges. Negative charges, what do you think? Will it flow from lower potential to higher potential or higher potential to lower potential? Think about it. One guy has a more negative potential and the other one has a lesser of a negative potential. Both are negative potential for now, assume. Absolutely, Vidwan, you can ask your doubt, and for education, I'll soon come to your doubt. And for education, still your doubt is not clear. So please post out your doubt completely. Try to explain it as much as possible. Of course, Vidhan, yeah, you can post your doubt. Okay. So gx square by something like I still didn't get your question for education. I may not be able to answer it, but you post out the complete question, I'll be able to answer it. Okay. So okay, now the thing is, what I'm asking is, there is a lesser negative potential which is at a higher potential. There is a more of a negative potential which is at a lower potential, of course, right? Now in that case, where has to be the charges flow from whether it has to, both will be equalizing at some midpoint, right? Midpoint potential. The charges in that case will flow from a lesser negative potential to a higher lesser negative potential. Lesser negative potential to a higher negative potential. So in case of negative charges, it will flow from more negative potential or more lesser value to that of higher value. Okay, let me write it down. So the second thing is, okay, there is a more interesting problem. Okay, let me do a thing. Quickly grab a sheet for you. Let me explain. First of all, first thing you understood, write it down, guys. Charges, positive charges, like charges, what we are talking about initially. Positive charges will flow from lesser negative potential, from lower potential, from higher potential to lower potential. From higher to lower potential, where two spheres are positively charged. You need to write it down. I'm anyways speaking about it, and you can just note it down. I'm stating it. Just write it down, guys. And if two spheres are of negative charges, charges will flow from lesser negative potential to that of higher negative potential, right? Lesser negative potential to that of higher negative potential. So how are they flowing? They are flowing from lower potential this could be match the following question. There are direct questions based on this. And now there is a third scenario if you are thinking about it. What's it out? No one is studying Muralidharan. Now, next comes the scenario where one is a positively charged sphere, the other is a negatively charged sphere. In that case, what is going to happen? So let me define the scenario again. One is a negative charged sphere and the other is a positive charged sphere. Now, what do you think is going to happen? Whether it is going to flow from a lower potential to higher potential, but higher potential to a lower potential. This is a very easy case. What do you think will happen? Okay, again two scenarios will arise where you have one sphere Q negative, let's keep it as something like Qn, and another sphere which is going to be like Q positive. Now the thing is, you have connected both the spheres. Okay, and as I told you in the beginning, one is going to be like positive charges on it. That is going to be negative. Two scenarios will arise in this case where Qn, let's say one scenario is like Q positive is greater than Q negative. Okay, I mean like mod of Q positive is greater than that of mod of Q negative, right? So in that case, it's quite simple. There are more number of positive charges. If they flow and eventually make this as positive, and this would also arrive to some positive equal radius. Radius are different. That's altogether a huge thing that you need to think about. So in that case, what is happening? All the charges will flow from positive to negative. Now another scenario arises where Q magnitude, the amount of charges on Q negative, that the negative charges on the sphere is greater than that of the positive. Okay, valid only when two spheres are of equal sizes. In that cases, what is happening? All the charges are going to flow from negative to positive or positive to negative to positive. So if you are noticing something very interesting over here. So one scenario where charges can flow from a higher potential to lower potential, another scenario where charges can flow from lower potential to higher potential. So two scenarios will exist. So potential is a thing that you need to be equating, not charges. This is equal radii charges, equal radii shells. So in this case, what is happening? Positive charge magnitude, okay, positive charges, it will flow from higher, like let's say define it this way. So positive charges will flow in the first scenario, so higher potential to lower potential when QP is greater than Qn. Okay, let me give this a name and this a name 2. Okay, this corresponds to scenario 1. Scenario 2, what is happening? It is flowing from lower potential to higher potential. This is scenario 2. This should be clear, guys. Alright, let's move on to the next question then, and we'll get started with actually this question was asked yesterday in the quiz. Now the thing is, the electrostatic potential in a given space is written in the following manner. Okay, It's going to be like some like sigma. This is like a chi. I don't know what this is. So this is going to be like phi is equal to phi naught x square plus y square plus z square, and where phi naught is a constant, then the charge density for the given potential is what? How do you work around these kind of problems? You know how to find out electric field. There are two concepts involved in them. First of all, you should get started with the concepts. Okay. First of all, you need to get started with the concepts. What are the two concepts? If you identify the concept, this problem is very easy. One is, of course, finding electric field from given, in this case, let's call it as just V, from the potential equation. Second thing would be what? Gauss law. Charge density for the given potential. Charge divided by volume. Let's do it then. It's a pretty simple question. Trust me, it's a very simple question. So first of all, you know something. Hi Mahendra, hi. Electric field is equal to minus of dou V by dou X I cap plus of dou V by dou Y J cap plus of dou V by dou Z K cap. Now, what happens? You take partial differentiation of this equation, and you know rho naught, sigma naught is constant. I'm going to take out that sigma naught as constant, and differentiation, partial differentiation, these two terms I'm not worried about during the first partial differentiation. We just did yesterday. It's going to be 2xi cap. Next one is going to be x square. You have partially differentiated. Now it's the turn for y square, because x square and z square are not going to be partially differentiated. You know this thing, I believe. Okay, 2y I cap plus of 2z k cap. Right now, it's a simple one. You got this equation, but this is, as I told you yesterday, this is the exact equation, j cap. Okay, typing it, j cap plus z of k cap. Guys, this is the exact equation for your electric field. Okay, a little bit of thing you need to understand as we move forward. Okay, I will explain you that thing right away, right now. Now think about it like this. There is an axis. This is the origin. Okay, carefully try to focus and think about it. Now the thing is, you are denoting a point in space, and I'm going to define a vector r. I'm saying this is going to be like xi cap plus yj cap plus zk cap. Can we call this as like a radii of a sphere? This should be clear. That's it. This can be written as r bar. Okay, let's keep it as r s bar. All right, that is it. And this is the point that you need to understand. Rest is simple. Now we got electric field equation, and we are calculating it for spherical structures. Okay, you understood this point over here. Okay, so now again the spherical structure came up, and now the thing is, you understood that we are operating around a spherical structure. Now the thing is, Now the question arises, what is the flux? Okay, question arises, what is the flux? Of course, you understood. We need to find out charge density. We need to find the enclosed charge. First of all, let's define flux. Then we'll move on. Flux is going to be E dot A. Electric field in the radial direction, xi cap plus yj cap, negative radial direction, but xi cap plus yj cap plus k cap. Okay, we'll take care of the sign while substituting it, so don't worry about it. For now, think about it, it's in the r cap direction. So they are both, the angle is 0 degrees, EA cos theta, EA cos 0, EA 1. And what is the value of area? Area is, in this case, its radius r, it's going to be 4 pi r. Simple. Now the next question arises. Okay, you said you're going to apply Gauss law. So Gauss law's another equation says this charge enclosed by epsilon naught is nothing but your electric flux. All right. So what is charge enclosed? Now let's say the sphere. Okay, we don't know whether it has a uniform charge density or non-uniform charge density, but actually from the electric field equation you can deduce something. Let's keep it as rho for now. Okay, we're not concerned about everything. We'll just keep it as rho for now. It's going to be rho into volume. If in this space, in the spherical space, the charge density corresponds to rho, what is the spatial charge density corresponds to rho? What is the charge enclosed, guys? Going to be, of course, volume into rho. That's what we have to do, right? We have been doing this throughout chapter, and you have to do this. And of course, there will be an epsilon over here. Okay. So charge enclosed is going to be rho into volume. What is volume in this case? 4 by 3 pi r cube. Okay. 4 by 3 pi r cube. So let me just quickly again. So we need to do this. Phi is equal to E into 4 pi r square is equal to rho, which we have to determine. We have to determine what? Charge density, not the charge enclosed. We can't even do that with the given options. We can't do that. Into 4 by 3 pi r cube divided by epsilon naught. Okay, this is Gauss law. This is definition of now. This is math. There's nothing else left in it. You need to basically you should understood that r point, like what it is. It was like r cap. So ultimately, your electric field, once you would have multiplied it, it's basically just, it would be another r cube. Okay, if you want, I'll come back to that point again and I'll explain that point. Maybe over here itself we can do that. So for now, let's do a thing. Before the dot, we will do a thing. We'll cancel out 4 pi r square r cube. What is left over? Just an r on this side, and we have something like this. What would be this? This would be mod of E. We are rho by 3 epsilon naught. Rho r by 3 epsilon naught. All right. Oh, I didn't get your question for education. What's your question? The question says x is equal to tan theta is equal to gx square divided by 2u square. Achha, you're asking. Okay, got it. I think you're speaking about projectile motion on an inclined plane, isn't it? Why don't you watch the video on projectile motion on inclined plane? You'll understand. I think you need to watch the second video on projectile motion on inclined plane. You'll get the answer. Okay. I got your question. I got your question. Okay. Now I got your question from the equation. Alright. Now from this, I need to put out another thing that would be, if I'm going to take mod. Okay. We defined this. Everything well and good. One, we have defined this. Okay. Other, we have defined this. If I'm going to take a mod, we said that, you know, it's basically negative direction. Don't miss out the negative thing. If I taken a dot product, there would be a negative sign, right? And in a mod of electric field, you're basically calculating the scalar quantity. Scalar quantities can be negative. Okay, this is R. Okay, this is minus 2 phi naught R. Okay, simple. I hope you understood this. This is the key to the solution. This is the key, right? You understood this? It's simple. Substitute everything and you will find out something interesting. So we have this equation. Scalar quantity of electric field is rho into R by 3 epsilon naught. But we just derived, we just wrote down something that this is nothing but 2 pi naught into R is equal to rho divided by 3 pi epsilon naught. What does the charge density indicate you? It indicates you that it's a uniform distribution of, if phi naught is greater than 0, the uniform distribution of negative charge. It's a uniform distribution of, it's uniform spatial distribution of which kind of charges? Of negative charges. I hope you got your the answer to your query for education of negative charges. Answer should be this. It's given in the options. Anyway, they have already given you the options. It's kind of uniform distribution of negative charges. And the third thing you should have identified is R vector, radial vector. Simple. Let's move on to the next concept then. Alright guys, this is a very interesting question actually, but a very simple one if you understood it. What is the point in this? Actually there's nothing much different. We have been dealing with concentric shells. Now the question arises, what if I've placed a charge cube or point charge cube inside this spherical shell, radius R. I'm trying to assess like at a distance R by 2 from the center, what would be its what would be the electric potential be. It's a simple case. Why don't you try it out, take a moment, try it out yourself, because this should be like a one-liner thing for many of you, because you understood the concept really well of shell, electrostatic inside cell. You would be able to do this. And guys, do cover all these videos during Diwali. Diwali is meant for this time and for you. Next, once you get into IITs and IITs, you will celebrate grand Diwalis. You will have your own tech fest. You will have your own cultural fest. So you have a lot of things to celebrate over there. But at the moment, if you do that, you will get that. But it's something that you need to give up at the moment. Like, I mean, give up means you have to ultimately not do at the moment or sacrifice. Not really sacrificing, right? You're planning for something bigger, like more celebration, to make use of this Diwali. Alright, this is a simple question. Let's get into this question. So what has been asked? Okay, if you read the question, a thin spherical conducting shell of radius R has Q charge distributed on it. Another Q charge is placed at the center. Then the electrostatic potential at a point P at a distance R by 2 from the center of the shell is on. It's a simple question, guys. So we have almost covered electric potential. So one more concept would be left over. But with that, we have almost covered electric potential concepts around spherical shells, different kind of structures. So cover it, guys. This can be the easiest thing that you can see in your exam. Trust me, electrostatic potential is a lot easier than electric field, less complications involved in it. For system of charges, how do you find out electrostatic potential at a point? Electrostatic potential on a spherical shell, on sphere, etc. And this could be easier than what you expect. So make sure. Hi Manindra, hi. So all right, let's quickly do this question. This question has nothing great in it. It's a very simple question. So just throw in that first of all, the surface that you want to understand, or a point at r/2 you want to understand. Now the thing is like, you know what, now what you need to do is you have two surfaces. Okay, one surface due to this charge q, and the other one is just a q itself. Okay, so the potential would arise at a point, let's say at r/2. The potential would arise due to two things. One is going to be your point charge q plus of that of spherical surface S2, which has charge distribution q in it. Okay, so that means all you need to do now is really simple. Just find out what is the potential at r/2 for charge q. It's kq by r/2. I know this is a very simple problem, but kind of confidence booster problem that you want to do and understand it really well. Even if it's a point charge inside, still it has a varying electric field and potential inside this shell. Now the thing is about surface to surface to, once you enter the surface, the potential is going to remain constant. It's going to become kq by, I think it was radius small r or capital R. Okay, capital R given to you. Okay, that is it. Kq by, same as the surface potential. Half radius, same things written twice. All right, so this can, if you have noticed, this is nothing but there would not be negative sign. This is not correct, this is not correct, this among this there would not be negative sign, so it could have been simply been said this I think so there is an issue in the given option. The answer should be not any of them. Let me quickly correct the answers given over here. So even though this is answers given, just a moment, stop subtitles and get into the answer part. When I'm going to write down the answer 1q should be absent. Yeah, and you get the answer. Okay, so don't worry, if you take out this is the answer, because what did we get? We got something like kq by r, which was nothing but like 1/4 pi, k is 1/4 pi epsilon naught, and in this case for point charge it was kq by r/2, which is nothing but kq by like 2 kq by r, and for the spherical shell surface it's basically kq by small like r itself. That's it. So this one would be the one that would be matching it. Alright, let's move on to the next interesting concept of the day. I don't know if you remember, for the center we have already done the derivation, but anyway, when we are going to do r/2, we'll do the derivation again. We'll come up with the standard equation. This is some kind of questions that you can expect in your JEE Advanced typically. Also nowadays, if it's asked in JEE Advanced, then you can expect it in JEE Mains. So now the question arises, there is a non-conducting sphere of radius r and it has a spatial charge density. Spatial charge density means, or volumetric charge density, or charges, non-conducting can have charges throughout its volume. And now what is being asked, it's a different kind of problem. Try to carefully notice it. Now rho varies with a distance, radial distance. That means for every radial distance, there would be a different, charge density associated with it. It's not a uniform charge density case as we saw in that question that we solved earlier. You got it to be like uniform charge density, if you remember, minus 6, phi naught, something like epsilon naught. But now they say that this charge density is no more uniform in this space. It is varying with every radial distance from the center. Rho is different at this point and the rho is different at this point. Okay. Now the thing is, it's not just about the amount of charges, but the charge density itself is varying with the radial distance. The ratio of electrostatic potential at the center to that of the surface is half. Take dielectric constant of the sphere to be 1. If there was a dielectric constant, you will multiply you divide it by the dielectric constant. Alright, now let's move on to this question, but I think the center problem you must have remembered it. We took shell by shell basis and did everything. We solved for each shell. We got something like, I remember the potential at the center to be AR by 3 epsilon naught. Capital R by 3 epsilon naught. Yeah. This was done in the last to last. Okay, you can calculate that. But anyway, during the next problem, you will get an idea of how to do it at the center. Okay, I'll derive for a standard equation and put it out so that you can make use of the rest. But this is the kind of thing that you get in the exam. Okay. Now let's get started on it. First of all, I need to find it for the surface. It's quite an easy problem. Think about it. On the surface, I need to find the potential at this point, which is, let's say, the surface of the sphere. Now if I'm talking about surface of the sphere, now the surface of the sphere has, if you understand this point, the surface of the sphere does not have any complication in it. It would act as if all the charges are focused at this. You can just take it to be like, even though the charge density is varying, I can take it to be a charge Qi that is all focused at the center. If you have any doubt, like how we did shell by shell basis, let's say this is a shell with some thickness dr and radius r from the center. And what would you do? You would find out first of all the charge density on that. It's going to be 4 pi r square. Let's keep it as also small r. Okay, 4 pi r square dr multiplied with the thickness. Then what do you observe? Okay, it's 4 pi r square dr multiplied with rho, which is going to be 4 pi r square dr into ar, which is going to be 4 pi r cube dra. When we are going to substitute the value of distance, what is the distance going to be? It's going to be capital R. What I'm saying is, there are two ways of doing it. One is thinking about multiple shells. These shells keep expanding and reach up until the surface. So for each shell, there will be a potential, and you would get the same thing as charge at the center. Okay, you can now you might have understood the derivation, how they are saying if there is a conducting sphere with the charge on it or on the surface of it, why can we assume it to be charge at the center? But this is not a session meant to derive that. It's basically to understand for a non-uniform charge distribution. Okay, not the postulate of Coulomb, but rather we are trying on our problem. Now, but if we are moving by postulate of Coulomb, we need to be confident about for a non-uniform charge distribution. For a non-uniform charge distribution, I am going to assume multiple such disks. Another disk. So for each disk, the potential is going to be different, and you can add up the potential. So first of all, we need to find out the value of dV. dV is going to be k into dq by radius r, which is going to be k into dq. What is dq, guys? It's basically 4 pi r square dr into rho, which is nothing but a into r. Okay, so it's a into r into rho divided by capital R's at some point outside the shell, divided by capital R. Right now, what you need to do, you need to simply substitute the value of rho, which is going to be k by r. I'm going to take 4 pi k by r into r cube, and a is also a constant. Okay, I'm just substituting rho is equal to ar. Okay, I've done nothing else. But taking, as usual, you're taking out the constants away. So if I'm going to say net potential at the surface, what you're trying to find out at the surface, guys, at the surface. I'll come to the other way as well. That's far more easier according to me. You take q at some point in the center. Same thing, you need to integrate dq. Here also you're only integrating dq. What are you doing? You're not doing anything else. You're only integrating dq, isn't it? Are you integrating anything other than dq? K and r are constant. Alright, so if I say potential at the surface, it's going to be what integration of dv from where to where? From 0 to capital R until that radius of that sphere. You would get it to be like 4 pi k a r divided by r, like 4 pi k a divided by r into r cube, small r cube, and there will be dr. Don't forget the dr. And now let's integrate it and get the answer quickly. So if we integrate the dv over the space, and v at the surface, it's going to be what we wrote it down to be like 4 pi, just a moment, let me recall it, 4 pi k into a into divided by r into r cube dr. Are you noticing something? 4 pi, this should be from 0 to capital R. 4 pi ka divided by r, integration of r cube dr. What is integration of r cube dr? R cube dr is as simple as, okay, it's as simple as r to the power 4 by 4, and this would be varying from or spanning from 0 to r. Substitute the values and quickly get the solution. Potential at the surface is going to be 4 pi ka r to the power 4 minus 0, so I'm not writing down that 0, divided by r, so r cube. What are we getting? We're basically getting 4 pi k, let's keep it as k, okay, what to show you something that would be so in this case, okay, this is only varying in terms of 1 r. If it was 2 r, you typically see a different scenario. It's not a very interesting, it's not like a universal truth, etc. Even in cases of charge distribution across the thing. Okay, so what did we get it to be? Okay, we need to substitute the values. I'm sorry guys, let me substitute the values. Also, let's write down this equation. So k, it's going to be 1 by 4 pi epsilon naught, and you have 4 pi ka. Okay, and you have something like r cube divided by 4. 4 pi gets cancelled. You have okay, again I'm writing down k, which is a mistake. That is where we have been doing it. Okay, it's going to be ar cube divided by 3. I think that was also at the center. There should have been a cube. Ar cube divided by 3 epsilon naught. Sorry, 4 epsilon naught. So we at the surface, we got it to be like AR cube divided by 4 epsilon naught or 3 epsilon naught, 4 epsilon naught, and at the center, so this is for surface, and at the center, if you derive it, it will come out to be AR cube 3 epsilon naught. So surface potential, I'll quickly show you how to derive it for center. So surface potential of center is to surface. Of course, at the center it has to be more than that of surface. It's going to be 4:3. Simple. I think I miswrote something over here. That would be AR cube. Simple, guys. Okay, if you are wondering how did we get it at the center, I'll quickly show you the derivation in less than 2 minutes. But for detailed solution and detailed understanding, do watch the previous video on electrostatics. So I need to find it out at the center. What did I say? There would be multiple such disks. Okay, there would be multiple such disks. Now the thing is, how do we do this? Basically, I would write down the dV equation. Due to each ring, I need to find out. So if this ring is contributing dV, many rings will be contributing such dVs, and this dV varies from 0 to R. How much is the dV due to the shell at the center? It's going to be K dQ by capital or small r? Small r. So just put out these equations. So this is going to be how much rho is given to us. You cannot use your own rho. So this is going to be 4 pi r square dr divided by r. R would get cancelled out, and r square and r would get cancelled out. 1 r would be remaining, and once you substitute the value of rho, you would understand this is nothing but 4 pi k a, and there would be r. So this is going to be 4 pi r square dr. It's a little quick, but you can watch the earlier video. You can understand it step by step how we are doing this. I think we have repeated 4 pi twice, so I might want to cut down on 4 pi. And if you integrate this equation, then you will get the potential at the center. Just a moment, I'm having a look at your question. Niranjan, I don't know about your hi Candle, hi. Niranjan, I'm really sorry, I'm not aware of NEET, but I believe physics you can do it. And if you're only planning for NEET aspirants, I don't recommend this for JEE Mains, JEE Advanced aspirants, because JEE Advanced aspirants ultimately have to prepare for JEE Mains and JEE Advanced. If your target is to get into IITs, so you will be preparing JEE Advanced level, but first of all, your qualification will come from JEE Mains. So you would have to do both for safety purpose as well. You have to prepare for JEE Mains. NEET aspirants, you have a shortcut focus on the thing that you have to do to succeed in your NEET. You need not take up problems from Iradao, you need not take up, maybe HC Verma is a good book as such, and DC Pandey is a good book. Move according to your syllabus, only try to address the level, whatever will be level, the difficulty level of the problems that is required for cracking NEET. You don't have to do Olympiad level physics to get into NEET. This is possible. Move strategically. I don't have data on NEET, so I cannot advise you as such, but I believe high weightage topics would be typically I think mechanics would have a lot of weightage in NEET. I'm not very sure, but current electricity, electrostatics, optics, you can cover them. I think I've analyzed your one of the syllabus that was like your optics, and your optics carries like around 20% of your syllabus. So one of the things that you can do is quickly pick up optics and complete it. Plus subscription, there is my course, you can start attending it. And but still, try to solve a very model problem. That should be good enough for NEET students, but try and make sure you understood every concept thoroughly. So the basic difference, I guess, is NEET is going to be less arithmetic oriented and more conceptual oriented, whereas your JEE Advanced is going to be more arithmetic and concept oriented. Okay. Yeah, and one more thing, have an aspiration, guys. Aspiration and your motivation drives you better than anything. Absolutely, you're welcome. You're welcome, Candle. Okay, so simple. Yeah, I hope you got your answer to the question. Better switch to need-based lectures. But if you're coming for physics, you can attend this physics lectures. You're always welcome. And the thing is, yeah, try to, even though you're learning concepts, try to solve need-based books rather than JEE-based books. Substitute the value of k. This would come out to be AR cubed by 3 epsilon. So a very short way of deriving. Okay. Simple one, guys. So take a ratio, you'll get it. So I should have changed it to AR cube. So yeah, this is how you get it. So no worries. You can check out last video to understand it in detail. Now let's move on to the next question. Here comes the most interesting question. Niranjan, possible. So which class you are in? Are you a 2021 aspirant? Yeah, guys, when you are coming for physics, try to focus on the concept. But candle discussion, that is true. That, but you know what? You should have a target, guys. When you're preparing for JEE, you can attend the classes to learn concepts, but at the same time, your target should be well defined. So Niranjan, it's not like you are going to switch your target every 2 months, 3 months. That is rather going to hamper your progress. You are a dropper. So half your year is finished. Okay, you have dropped out already. I think JEE might be a better bet than a NEET. The reason why JEE might be a better bet than a NEET is you have a math in JEE. There you don't have a math. So math and physics will go hand in hand. So that way, Niranjan, what you can do is you can focus on JEE Mains for the next scheduled month. You're absolutely welcome, candle discussion. Absolutely, guys. Yeah, your love for physics should remain constant, irrespective of anything. But the thing is, you know what, Niranjan, I think JEE Mains might be the best bet at the moment. If you are not very good with memory, if you don't have access to coaching institutes at the moment, I think JEE Mains is a better bet. You can start today. You can start covering the lectures online itself, and math and physics would go hand in hand. If you haven't started any preparation yet, you can do it. Okay, that thing I can somewhat kind of confidently state. Rather than NEET, I'm not aware of it. The reason why I'm saying JEE Mains might be a best bet for you if you move very strategically. Do watch the strategy videos. One would be physics. You can move very strategically and only take up those things where within 5 months you're covering a significant. And math also you can do something similar, and both would go hand in hand. That way you will be able to get it. And choose physical chemistry, because physical chemistry is again going to be like arithmetic oriented, and you will spend less time. Okay, I hope you got your answer, and maybe next one would be organic if time is left. But physical is like 40-50% of your papers. Somehow you'll be able to easily succeed in. So this is a safe route. It depends upon your passion, like what most of the students are saying. Just don't move according to the target. Sometimes move according to the passion. If you want to be a doctor, ultimately JEE is not going to. Okay. All right, guys. True, but what about biology? So, candle discussion, there is a thing. You're welcome, Niranjan. Yeah, that is true. But what about biology? Biology is a thing, right? That we can't really say we know it. So there lies the issue, really. Okay, you can prepare for JEE and you can crack the chemistry and the physics part like a piece of cake. That is true to a great extent. That is true. But when it comes to biology, there is a lot of learning involved in it. I believe there is a lot of learning involved in it. Alright, guys, let's get into this problem. Then this is more interesting than the before one because let's see what is being asked in the question. Now you have a non-conducting sphere of radius r and it has a spatial charge density rho distributed throughout its volume. Same kind of spatial charge density, varying spatial charge density with respect to radial function. Rho is equal to a into r. Now the question arises, what is the potential not at a but at a distance r by 2 from the center of the sphere? Try to get started on your own, guys. Very important. Okay, amazing candle discussion. I didn't know about it because I've never chosen biology, so I'm not aware of it. But that's amazing. That's really good to know. Yeah. So all right, now the question arises: how do you work around this problem? But get started on it. At least write down the first few steps. It will be very easy. It's a very damn easy problem. Trust me, it's a super easy problem. Now, two scenarios will exist. This two potentials that will be overlapped. What are those two potentials? Let's have a look at it. So, at a distance r by 2, let's assume this is the distance r by 2. I'm going to first of all draw the sphere. So, at a distance r by 2, carefully notice two things. One, okay, you remember how we did it for like uniform charge distribution? Same thing, there's no difference. It's the same thing. One, you have charge distribution inside. Other, you have charge distribution outside. For inside, there would be a potential at point r by 2. For outside as well, it's like, distance or potential varying disks. Sorry, I'm saying disk, but shells present at different distance. So one is due to that outside one. Okay, so if I'm going to state what is the potential at distance r by 2, we would be defining two kind of potentials. Potentials at a distance r by 2, just like how we did it for our conducting case, sorry, uniform charge distribution cases. Conducting case is very easy. It's basically connected potential should be equal. But for that, non-conducting case, how we did it at a distance a inside the space, it's the same kind of thing. It's basically a little bit more math. Okay. So one would be due to the potential of the solid sphere present inside. You can say as if all the charges are concentrated at the center of that solid sphere and they are creating a potential at distance r by 2. And the other one would be due to the outside shells where you would be adding all the surface potential. Simple. Now, what you need to know? Nothing. It's a simple math-based problem. I told you in the beginning. In fact, if you have understood something, you can make use of the thing that we had discussed before. So whether I should be doing that or not, let's see. So if you remember, if you're not, if you don't remember, just do it again. So one, I'm going to talk about inner now. Inner, how we did it, we said that this is nothing but due to dV, and there were like shells inside, and they are creating a potential at r by 2. Okay, they are creating a potential at r by 2. And we said this was nothing but k dq by r by 2 or r by 2, right? Not even small r by 2 outside some point for the shells. Instead, what did we derive last time? We derived something like a into r cube by 4 epsilon naught. We do something like this. Instead of r, can I substitute it as r by 2? Because we already derived it, we know it. It's the same process, guys. If you're a little bit skeptical even about it, derive it again, you'll get the same expression. There would not be any change in it. Okay, so this is what V inner. Let me first of all write it down as V inner. Okay, it's the same thing. Let me quickly at this point. Okay, all right. So V inner or VQ, I inner, etc. due to charge inside, it's going to be how much? R cube, r by 2 whole cube, 8 into 4, 32. If you have understood, or even if you have memorized it a bit, you should not be doing that logically in these kind of questions. So there would be a 32 on the day. I just leverage the same equation. I'll be finally coming up with an expression, so don't worry about it. So you can make use of that expression, but you know what? This is a model problem. This is, if it was uniform charge distribution, it makes more sense to remember and graph and everything, because that can be asked. But now in this scenario, you may not want to necessarily memorize it, but rather understand what is being done. I would typically recommend that. Okay, there is no use of memorizing the expression that I'm going to write, but the way it is supposed to be done. Okay, so probably if you even remember this a little bit from the options, you can guess the the answer, but that is not our objective. Our objective is to understand something more. Okay, now the second scenario arises. Let me take a different color for the second scenario and let's understand this. So the second scenario arises where you're going to count outside shell, and typically we can make use of the center based thing, but this time your radius is going to vary from where to where? From r by 2. This point is r by 2 to how much? R. Okay, to r. It's simple, guys. It's simple. Just focus and you'll get the answer. In fact, we did all the derivations that is required for the earlier one. So it is as if this shell is varying from distance r by 2 to r. You imagine this shell to be going from r by 2 to r. Each shell's potential would be added. So we call this as Q outer. So potential due to Q outer, it's going to be what? Integration of K of dq divided by r by r, capital R or small r. I mean like capital R by 2 or smaller. It would be smaller. The same situation would arise. It will be like a into r into 4 pi r square. Everything is a small r. Everything is a small r. 1 r would get cancelled from the AR. So think about it carefully. It's the same thing. Nothing has changed. I'm just going to write it down as 4 pi k a. 1 r has been cancelled out in that row. The same equation. You would have what? R square dr integrated over how much? 0 to r. Oh, sorry. This is my mistake. It's r by 2 to r. So not 0 to r outside shells. It's r by 2 to r. That means we are arriving to some interesting solution. Okay, so due to outside shell, what is the potential? Just do the math. It's a lot of math now, and you have like r square minus r cube. There would be a 3 outside, r cube minus, okay, integration of r square dr is going to be what? R cube. Okay, it's the same thing, right? Just we derived it for the center. So it's going to be what? R cube divided by 3. R by 2 to r. Solve it on your own, guys. And you substitute this. I took out the 3 out as common. So it's going to be r square minus r cube. Again, I'm writing it down wrong. So just a moment, let me correct this. So r cube minus r cube by 8. So this is going to be like 7 r cube by 8. Okay. So now what is the potential? Okay, let's write it down on the next page then. Okay, let's write it down like this. Let me quickly choose the pen. So 4 pi into k, what it is? 1 by epsilon naught. 4 pi into k is 1 by epsilon naught. So we would have something like a by 3 epsilon naught and into 7 by 7 r cube by 8. There you add something like I think it was like a r cube divided by 32 epsilon naught. Now we are having 7 a r cube divided by 24 epsilon naught. So we got another equation, v q outside, due to this outside shells, we observed something like 7ar cube 24 epsilon naught. Right? Simple as that. Now there are two things. Let me do a thing. Let me quickly again do a thing that would be useful for your understanding if you have been confused. I have the sphere, and what did we have? We had an inner charge which we haven't written yet, and we add an outer one. Okay, now inner one, if you remember, we derived it to be actually I told you a trick for that. You can make use of that expression that we derived for the surface, and if you exactly extrapolate that thing, it was for the inside one, it would have been ar cube by 4, keep it a small r, by 4 epsilon naught. Substitute that small r is equal to r by 2, you would get it as ar cube by 32 epsilon naught. Now what is the total potential, guys, or the potential actually, r by 2, which is going to be due to two components. One due to outside one that we just derived, or that we just calculated. 7ar cube divided by 24 epsilon naught. Rest is math. You know what to do and how to derive this. It's a simple thing that you need to do. Ar cube by 32 epsilon naught. Simply do the math and try to intuit what would it be, what is the common LCM should be in this case. One is 32, other one is 34 or 24. So 96 is where I believe they both would be matching out each other, because 24 4s are 96 and 32 3s are 96. Okay, else if you have any such issues, take out you know this thing. This is 8 into 4, this is 8 into 3. 8 would be common, 3 4 it would be rather easy. Okay, so here I'll be multiplying with 4, here I'll be multiplying with 3, so this would be 31 by 96 ar cube epsilon naught. So potential at r by 2, I'm just carrying out the same equation. I did the math. That is nothing else. You can that is nothing like a bit a huge thing that you need to work around. You just simply do it. Basically I said it's 28 plus 3, it's 31 divided by ar cube 32, sorry, 96, it cannot be 32, that's totally wrong. 96 epsilon naught. Now let's understand something. See, this is a non-uniform charge distribution. This is a non-uniform charge distribution where we were trying to assess a potential at a point r by 2 from the center inside a non-uniform charge distributed non-conducting sphere. But if you have noticed something, we had two expressions. What was at center? It was ar cube by 3 epsilon naught. What was at the surface? It was ar cube by 4 epsilon naught. And notice something interesting. Even though it is a non-uniform charge distribution, d at r by 2 is going to be greater than that of v at surface, which is going to be less than that of v at center. Potential at the center would be maximum. Even though it's a non-uniform charge distribution inside a non-conducting sphere, what happened? You observe that potential at r by 2 is less than that of center and greater than that of surface. So is it true for every single thing in like in this case? Let's see. Okay, let's understand that point. So what I'm going to do is I'm going to write down the generalized equation, but the generalized equation I got it from nowhere. I got it from whatever derivation that we have done. So I'm basically recalling those. I will recall it while we are solving it now. I mean, like while we're writing it down now. So we had, okay, this is at any point x. Okay, any point x from the center. Okay, not very important to remember, guys. This is only to understand. This is just for understanding. Non-conducting, you don't have to remember it. Sorry, non-conducting, non-uniform charge distribution. Each time you'll get a different model. You don't have to necessarily remember it. Two kinds exist. One, due to the outside space where like your r is greater than x, and other one where your r is less than x. Point number one. Point number two, we derived an equation for r inside x. Okay, let me do a thing. Let me quickly change this thing into two parts because that would be useful for our understanding when we go systematically. So where r is less than x, other one is r is greater than x, and let me draw the sphere and explain this. All right, just give me. And one part is r is greater than x, r is less than x. Again, I'm sorry, r is less than x, where all the shells are inside that thing, and the other one is where r is greater than x. So one would be q inside, one would be q outside, as we defined earlier. You would be doing that, but you can take a shortcut in this. Always try to understand whatever you have derived for one of them can be leveraged for other one while you're doing it in an exam. Let's say they asked you for r by 2 and r by 4. First derive for just an r, like an x or something, and then put out the equation. Okay, and understand that there will be two kinds of potential that are being, that will have a, we'll do a superposition of two potential. So inside, if you remember, the expression was something like a r cube divided by 4 pi epsilon naught, just due to inside charge, right? Just due to inside charge, what it was, a, this time I'm going to write it down as x cube. There it was r by 2 whole cube by 4 pi, 3 pi epsilon naught. Okay, I'm not even going to condense this equation something, it's just for your understanding. I'm only going to condense a small part of it, and just for your understand the point. And the other one was something like a by 4 pi epsilon naught. That's what we had in the other case. That is where r is greater than r by x. And the final equation, going correctly, just just a moment, guys. I'm just saying that. All right. You must be here. Just a moment, guys. Oh. Be 4, 3, 4. Just a moment. I'm just taking a pause. Take us up. No, how did we get the answer though? That's a little terrifying. I wait for the center. I think we did. There should be 3, right? I think a little change in the problem. This should have been 3. So this would be how much? 24. This should be 3, right? This would be like 3 epsilon naught. Hence this would be how much? This would be like 8 into 3, 24. And in the other place, I think this would be like a 4. Of course, 4. How did I carry out 3? This would be a 4, and you would get something like the same thing would be appearing, but here it would be like a 4, and this would be a 32. The common denominator is going to be 96, but now this would be 32. Let me quickly correct this, else our entire calculation went into ditch. So anyway, just carry forward that equation, and the small mistake I've done in that. So this would be like 24 r cube by 3. Yeah, this is going to be 24, and that also says this is going to be like okay, this would also be 32, this would be 24, and okay, let me quickly correct. Okay, 24. So simply now it's a simple math. Sorry guys, a small correction, please do make that correction. You should derive it on your own. That's the reason you should practice it. So this will be 21 plus that of 4, this is going to be 25. In fact, the options that I brought up. Okay, let me just quickly verify it. 3 times 21 plus 4, 25. 25 should have been the option. There is no such option over here, so it should have been when you should be getting something like 25 by 96 ar cube epsilon naught. All right. So anyway, I'll write down the final equation, and you need to once do it on your own. And of course, this should have been I don't know why this happened. All right, let me not confuse you. Let me redo this again. This is at a distance x. This is a distance where r is less than x. Rest is all fine, guys. Where r is greater than x. This will be charge inside. This will be charge outside. Now what do I mean to say is, in such situations when you are given non-uniform charge distribution where you don't have a standard expression, or even if it's a charge distribution with a uniform charge distribution, both a non-conducting sphere with uniform charge distribution or with a non-uniform charge distribution, you have to do something like this. What do you have to do? You'd have to say, okay, I have to find out the potential at a point x, which is inside a point inside that non-conducting sphere. In this case, this non-conducting sphere has a non-uniform charge distribution, and there will be two kinds of things that you want to add up, where the radial distance is less than x, and the other one where the radial distance is greater than x. Okay, all right. As I told you, you don't have to remember this thing. It is just for your understanding. Inside, it would be as if that entire charge qi is concentrated at the center. Even if you integrate dq, which is what we did, right? We integrated k dq divided by r. It is as if every charge is concentrated at the center. So you will get an expression something like a x cube divided by 3 epsilon naught. And in the other one, when r is greater than x, you are going to write down each shell. You are going to draw each shell, and you will be working around that each of the shell. Each small shell will come up, and that small shell would ultimately vary from a distance where to where, guys? Where to where? R square minus of x square. This minus x square is not because there is some minus negative x cube. Again, r cube minus x cube. This minus is not because you have some potential difference, etc. It's because you are integrating from r to x. It's simply calculating all the disk between x to r. Okay, that's it, guys. That's it. And if you notice this equation, take out a by epsilon naught as common. Let me do it on the next page quickly, or let's write it over here. Take out a by epsilon naught as common, and you'll see one is x cube by 3, other is like x cube by 4, x cube by 3 minus of x cube by 4, right? You'll get something like somehow feel something is going wrong. This is that thing that is going. Something is going on. Because it cannot be a square r cube plus of something. It should have been minus of something, because at the center you are going to have the maximum. Did I mess up the the initial calculation? Thinking did I mess up the second calculation? Don't think so. This will be like 4 by 3, 4 by r square, rho will be r cube dr. Oh, yeah, I think we messed up during the second. That means at the center it is less than that of surface. Is that what we are getting in this case? How is that possible though? I think what we did is correct, guys. Actually, what we did is correct. I think we may have to once again have a look at this thing. So here it's going to be 3, it's not going to be 4. So what has gone wrong is everything was right until now. We just changed it to a wrong one. But I have a concern at this point. Is okay, correct. Yeah, it's my mistake. It's my mistake, guys. Okay, all right. So yes, so this would be what 3 into so this would just keep it as 3. So everything was fine up until now. So yes, it's my mistake. Let me explain you what I was thinking about. So this would be what 24. This would be 32. I think the answer exists. Small correction. Please to make this correction. Yeah. Okay. So let me quickly brief you. So initially it was all correct. You don't have to correct anything now. So anyway, so yes, this is what it was supposed to be. But I think I finally changed it to a wrong equation. I think that is where the entire concept. But 1 4s are okay. 96 would be as 96. What I need to resist 25. 31 by 32. Of course, it cannot be 25 by. This should be like 31 divided by 96. It cannot be 25 divided by. That means it's lesser than. It could be okay. Anyway, a short correction. Please do make this correction. Yeah, I think. The potential at the center should be max, students. That is correct. Whatever you have stated is correct. Yeah, we have made a calculation mistake, a small calculation mistake. Do correct it. Of course, here is there. No, I think everything is fine. Absolutely fine. I think while arriving to this, memory-based thing, we made the mistake. And let me quickly correct it. I think I have got stuck at this point. So x. Where x is greater than r, x is greater than where r is greater than x. Quickly corrected where r is greater than x, and the other one where r is less than x. There would be charge inside and there will be a charge outside. Now comes like whenever and wherever you are calculating the potential. Let me repeat it. I'm really very sorry. So let's say I have to calculate potential at x. You do some r less than x. And you do another condition where r is going to be greater than x. When r is going to be greater than x, it's basically it is basically shell's surface potential. When r is less than x, it is as if all the charges are concentrated at the center. In this specific case, we got it to be ax cube divided by 3 epsilon naught. And in this specific case, why am I saying in this specific case? In this specific case, I'm intentionally stating because it's a non-uniform charge distribution where rho is varying with only radial distance once. Okay, a r to the power 1 power it is varying. Now, if it was any other case, you would notice some other expression, but still one thing would be always be true, which is where I got the confusion. V at center should be always be greater than V at r by 2 should be greater than V at s, like what candle discussion is saying. That is true. Okay, rest I think every calculation was correct. It was the second mistake, so don't correct it when I said the second time. Rest I guess is fine. So if I finally write down this equation, you'll from this expression we can understand this. This is what I wanted you to understand. Let's turn it as like 12 epsilon naught. What would we get over here? Here we would get something like 3r square minus x square. Okay, let me rewrite this equation. So in this specific case, potential at a distance x, at a radial distance x from the center, what did we get? We got something like a by 12 epsilon naught. I'm just rewriting the same equation, is equal to r cube 3r cube minus x cube. That is it. So alright, I believe from this you can see that the maximum potential would be at the center. As x increases, potential decreases, be it even non-uniform charge distribution. This is the point where I wanted to bring, and everything we messed up. Let me correct it. Hi Vishal, hi, hello guys. So yes, even if it's a non-uniform charge distribution, what you have observed, non-uniform charge distribution, you're still observing the same phenomena as you are observing in the uniform charge distribution. In the uniform charge distribution, you saw that if Q charge was uniformly distributed throughout the sphere, it was 3Q by 2r, whereas on the surface it's going to be kq by r, as if all the charges are focused at the center, okay, or all concentrated at the center. But it's the same kind of process. Hence, you would always observe that as this distance from the center increases, potential keeps decreasing, and it would be minimum at the surface and maximum at the center. Okay, minimum at the surface and maximum at the center. And this is also true for non-uniform charge distribution. So think about it carefully. All surface potential being added, where the value of r is kind of increasing, which means the potential is also increasing. And other case where all you're calculating is like all the charges focused at the center and r remaining constant, where that r is always greater than x. One way of thinking about it. Alright guys, I think this is for today. I'm really sorry about that last correction, but make that correction. I hope you understand rest of the concepts. You practice on your own and make sure you are covering electric potential. And I believe with this, we may not have any problem around electric potential, but we'll be moving forward to the rest of the topics. Before that, this Diwali holiday should be for your revision, and make sure you're attending the most competitive gamified IIT JEE battle ever, so that you can win live. You can compete live and win lots of rewards and prizes, which includes Amazon voucher and more like Apple products. Guys, the first winners would be like awarded Apple products like MacBook Air, etc. And yes, this is the second time it is happening on 22nd of November. Do not forget to enroll with Murli live code and enroll today, guys, so that you can get started and get yourself warmed up, especially if you're a JEE aspirant. This is something that you want to do. Happy Diwali guys, happy Diwali, and do not forget to click on this like button and subscribe button and share this video. It's going to be a very interesting session moving forward. Be regular and do not forget to attend this most competitive gamified IIT JEE battle ever. And that being said, if you're already on plus, enroll soon to this Optics Basics to Advanced coursework. This Optics to Basic Advanced coursework is a complete coursework on optics, in which we'll be covering both ray optics and wave optics, and that too in 60 sessions. So imagine 100 plus concept, 300 plus model problems, and it has just been launched. If you're already on plus, start covering the recorded videos during this vacation or this 3 days holidays. And not only that, if you're planning to purchase subscription, this is the time to do it and enroll to this coursework. And that being said, our team is also on plus. We have started courses on electromagnetism and optics B2A basics to advanced coursework, where you'll be going from basics until advanced, guys. So make sure you're attending that session as well, and differential calculus and chemical kinematics. And this is for 2021 aspirants. Our team, JEE English team, also has plus courses for 2022 aspirants on graph sets, relation, redox and equivalent reaction, and advanced course on mechanics. And that being said, not only come to lectures regularly, but also share this lectures so that your friends can also learn. But more importantly, work smart and hard to achieve your success, acquire knowledge and share it so that your friends also get access to the knowledge. And also students who are looking for free of cost quality lectures, they also get access to such amazing lectures. And that being said, students, if you're already on Telegram app, you have this link in the description box below. Just click on to this. If you don't have one, download it from Google Play Store and App Store. It's going to be like a a different app which you need to download, and then click onto this link and you will be able to find us, where you will get before time updates on every class happening on JEE English. And that being said, students, if you haven't yet started with units, dimensions and measurements yet, you are making a mistake if you are a 2021 aspirant or a dropper. Why? Because this is the easiest topic where you can grab your marks without any hassle, and you don't have to put in much efforts. And not only that, you typically get 1 or 2 questions every time in your JEE Mains, guys. Combined with JEE Advanced, it's going to be like anywhere 3 questions that you're going to see in this season. So make sure you're attending this. This is the easiest one, less time consuming one. All you can do is, all you have to do is attend these 4 back-to-back session plus a 5th model problem session. With this, you'll be complete with your preparation. It's a complete lectures, guys. It's a complete lectures on units, dimensions and measurements, all available right now for free of cost on Unacademy learning app. So make sure you're attending it, and easiest for your exam as well. What do I mean by easiest? In your exam as well, it will consume less time. It's going to be that easy part. Hence, this is a must-do topic, guys. And absolutely, guys. That being said, if you don't have an Unacademy learning app yet, do download it from your Google Play Store and App Store by just typing in Unacademy, and you will be able to find us on both Play Store and App Store. And once you search, the first search result is going to be Unacademy learning app. Just click on to this install button once you click on to this link, and guys, what do you get? On time updates, and you can attend Unacademy Combat. Yes, what else do you want? And free quizzes. So yes, there are many reasons to download it, but these would be the best reasons for you. And that being said, students, if you are looking for a Champions Tool, a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription. Why? You are going to learn from the best educators across the nation on a daily interactive classes. Not only about daily interactive classes, but you are going to undergo a structured program, an intensive and extensive structured program, where what it means is you are going to get scheduled doubt clearing sessions after each topic. That way you're able to maintain completeness, and you'll be attending quizzes and mega quizzes, and more importantly, national level test series keep happening on Unacademy subscription platform. And guys, yes, it's going to be like your JEE environment. So what else do you need? And we also have legends like DC Pandey sir on this platform. And all you need to do is click on the left hand top corner extension bar, choose IIT JEE as the goal, and then click on this get subscription button. And with this, you get 1 subscription. It's going to be unlimited access. And that being said, students, this all comes at a price of less than 70 rupees a day, 2,100 per month. Less than 70 rupees a day is what you're going to find you're going to pay for this kind of fine platform and fine preparation programs. Not just a platform, it's your preparation program for your JEE Mains and JEE Advanced. You can prepare from anywhere. And 9th class, 10th class and 8th class students, this is typically meant for you, along with 11th class students. And apply Murlidharan coupon and get the best discount. And to this price point, do not forget to apply Murlidharan coupon to get the best discount. So this is how you'll get the best discount. Don't miss out any discounts on your subscription purchase. You can apply Murlidharan and avail any discount on any part of your subscription. And that being said, you can split your payments into multiple parts using our in-house payment feature, pay in parts. We also have access to no cost EMI, where you don't have to pay the interest for your EMIs, guys. So this is the awesome thing about Unacademy subscription, and you don't have to pay the burden, bear the burden of paying all the fee at once. You don't have to bear the interest on your easy monthly installments. And these are 2 interesting payment options that you may want to check out. And we also have access to debit card, credit card, UPIs, etc. And if you're a long-term and dropout, a 12-month program is for you, typically for a long-term and a dropout students, and also 12th class students. So it depends upon where you are in your preparation. And guys, it's generally a 2-year-long journey. But if you're a long-term dropper, we have dedicated droppers batch, we have 6,000 plus materials, and we have 1,000 plus live programs going on, and all at a cost of only less than 2,888 only. And do not forget to apply Murlidharan coupon to get the best discount on any of your subscription purchase and to get to this price point. And that being said, take care, stay safe, bye bye, see you in the next class. Make sure you're making use of this Diwali and finishing the classes that you have to, and keep this target in mind, and do not stay fickle minded, and that is going to consume your energy. Make sure you are completing the classes, you are staying dedicated, and of course enjoy your Diwali, enjoy your every vacation that is going to come from now onwards. You will be seeing a lot of vacation, but these vacations are for your preparation, especially if you're a dropper or if you're in 12th class and if you're aspiring to prepare for JEE Mains and getting into IITs and NITs. All right, guys, make sure you're making good use of this time, and like this video. See you in the next class. Take care, stay safe. Bye bye, guys.